Hello, good morning, everyone. Welcome to the final anticipatory briefing of the 2025 edition of GESDA. We're going to talk about the future of advanced AI. Artificial intelligence is entering a new phase. We've seen that all around us. We're moving beyond language models to architectures designed for reasoning, planning, and purposeful action. How will advanced AI transform science, industry, and global governance over the next 5, 10, and 25 years? That's going to be the topic of a 15-minute presentation by our speaker, followed by 15 minutes of questions with the audience. Our speaker today is the president and university professor at the Mohamed bin Zayed University of Artificial Intelligence in Abu Dhabi. But he also teaches at one of the birthplaces of artificial intelligence, where the first program considered to be artificial intelligence was made in the 1950s, which is Carnegie Mellon. Please help me welcome Eric Xing.
Thank you. Well, good morning, everyone. Thank you very much for having me. I want to begin by thanking GESDA for giving me this opportunity to share with you some of the work that we do in Abu Dhabi, in Carnegie Mellon. I was asked to do the impossible mission of making predictions for the future of AI. I'm not very good at that, because the problem is very difficult. We don't really even know, what is intelligence, not alone artificial intelligence. For example, we used to think solving big physics problem, math problem, is intelligent. Therefore, Einstein is obviously intelligent people. We used to think that memorizing, information is not intelligent. But Mozart is an intelligent musician because he was first known for going to Vatican, hear a piece of music for one time, and then reproduce a score out of memory. That's memorization, and we call it intelligent. So people are having debates about what really is intelligent. Now, talking about the AI systems that we are having, we saw some amazing results in the past few months, in fact, past few weeks, right? OpenAI and Gemini both won gold medal or had a gold medal performance in the International Olympic Mathematics Games. And recently, they also do very well in the International Mathematics International Olympia of Advanced Physics and Astronomy. Right? So they are smart or not? Well, let's do something else. How this same model understand our universe, our surrounding. For example, this is a picture. I ask a dumb question. You can all answer. Is this individual fellow standing on the right helping this lady or not? You will be shocked by the answer from, say, GPT-5, the very, very latest version that I tried even yesterday, and that's the answer you get. And you can also ask an advanced version of GPT-5, which is GPT-5 Think, which will take longer time to think. It becomes less certain, but still feel like it is helping. In fact, you can go to the deep research, and which will spend half an hour giving you pages of answers, analyzing why it is helping. Right? And there are also some other questions. People actually figure out a leaderboard which tests various opportunity, problems like physical understanding and maybe motion understanding and so forth. And this is one of these test examples. And we can all answer, are these two objects moving in the same trajectory or not? Right? So this is the answer from 01, 03. One more example, are they of the same size? Which one is bigger? You can all answer. Somehow, our AI system cannot figure it out. So in a sense, measuring intelligence, such as by the Turing test, is a ill-defined question because it is really trying to match a machine against a human. And in the sense of sometimes a subjective feeling, not even an objective measurement of goodness. So here, I think one direction or one thing that will happen in the future of AI is that the very measurement of how AI performs and how we can understand AI will be changing. It is probably going to be focusing more on capacity and utility rather than this very subjective sentimental feeling. Right? So purpose, in a sense, not sensation or stumps, will be driving intelligence. So we see some scientists embracing this view already. This is a little tweet I got from Terry. And he was using GPT-5 to solve some very advanced math problem. And here is a very interesting conclusion. He said that, hey, GPT-5 is doing fine and helpful in small scale, maybe helping me to derive a few steps. It is not doing so well and not so helpful. The word helpful is very important at the mid scale. And it becomes helpful again in the larger scale, meaning that the bigger picture, the direction is kind of okay. Right? So it's a very, very nice way of now assessing any intelligent systems, but it is probably not the view in the public. Public are still kind of more engaging with a more sentimental feeling. So here, I want to pull the conversation back, again, on utility. We people, or human beings, have this pyramid of needs. Right? This is Maslow's pyramid of the human desire and the human needs. It is based on those needs we developed all the capacities, like in here, doing writing, reading, reasoning, organization, building strategies, tactics, and so forth. And you can actually measure them in terms of the level of difficulties. Of course, at the top is what I'm asked to do right now, to be a prophet, which is very, very difficult. But I can be a little more certain about what is beneath that. For example, we know that the large language model is now doing the reading and the writing. If you consider that to be intelligent, I think it is. Right? But if you ask a large language model to do action, to do planning and strategizing, we need something else because we already saw some examples where it doesn't work. Right? So that's how we could imagine now the space of the problems and challenges. Here is LM. Oh, I lost the animations. I'm supposed to show you the inner ring, which is just that ring of language space. And then when you want to go to the physical world, say, for example, making this picture alive so that you walk into it, like this, then you need to know the physical reality around you, right? How to navigate inside it. That's basically what we mean by space and time. It's a different space of reasoning, which is beyond large language model. That's why large language model isn't working. Right? You can also add a little figure into this world, which we call an agent. Well, this figure may have all sorts of tasks to finish. Maybe he also has some sentiment and affection to other people or to the view. That means you need to enter yet another newer space, a bigger space of reasoning, which we call multi-agency space. And ultimately, you want to understand science, like Einstein did, which needs to understand now the law of nature. That's an even bigger space of reasoning. So by that way, we start to see at least a roadmap of problems that our AI may be able to chart and also chart a map. And now maybe one useful exercise we have to do is that eventually what we want to just achieve. Right? I started from the top and then go all the way down to our reality. Anybody probably heard about this science fiction, Dawn, right? Which actually is about a supernatural agent which can do amazing things. Right? This agent named Quasar is able to solve galactic problems, waging a war in the galaxy, doing a global project like turning desert into the sea and so forth. And the way he does it is actually a form of advanced reasoning, which is called simulational reasoning. Because according to the book, he inherits all the memories of his ancestor and also of his peers. And then before he solves any problem, he's going to do some thought experiment in his brain. And then if it worked, or if one of the plan worked, he would execute it. It's a very, very interesting way. That is similar to how a computer could be built, because a computer offers you the capability of simulating in this ever-growing level of complexities. So now I ask, maybe the future 5, 10, 25 years can be framed as at what functional level, at what level of reasoning space our system can achieve. And then we can ask, can we achieve the superhuman capability or not? For example, here is my personal list of future problems. We are already here. We can now ask an agent to help me writing an email. Many of my colleagues are using the ChatGPT to write essays and speech and so forth. So LM is a perfect simulator doing just that. But you can ask bigger questions. How to drive a car, how to basically settle down on Mars, Maybe, okay, now going back to the trivial thing, booking a ticket, in a very, very complex market of providers. That's about multi-agency problem. Or we treat diseases, invent a new drug, and so forth. All these problems, actually is somewhere lying in the space I just laid out. And that's how we could see a future look like. You can build a simulator of human cognition, a simulator of the whole world, a simulator of the nature, so that you can start doing this simulative reasoning. Right? So in that sense, I will try to answer this question about what's happening in the next 5 years, and 10 years, and 25 years, because I'm not really sure, so I put a question mark there. There is a model called the word model. So how a perfect word model should look like? Well, a perfect word model should allow you to do your possibility and simulate all possibility in the virtual world, such as physical, sensory, embodied experiences, even human emotion, mental world, social experiences. And we can try to ask, is that going to happen in 5 years? I don't know, but I know people are actively working on that. That's probably the first step happening before the next step, which is an agent model. Because you want to now produce agents, or maybe allowing us to experience such a virtual world or reality to do different tasks. And the one very, very important nature of an artificial intelligence agent is that it should be like human, which is able to perpetually learn, even learn from one instance, not through big data, and also maybe interactively extract more experiences from your learning, engage in the world. And that's basically requiring the word model to be first there to allow simulation to happen. You don't, for example, send a person to the Mars first before even telling him how to navigate and work on Mars. He has to experience everything on Earth, hopefully through a digital simulator, before he goes to that very daring venture. I think this will be the norm in the future for any exploration. In the longer term, we could even imagine that our very self, as an organism, as a biological organism, can be also simulated. And here there's a vision championed by many scientists called AI-driven digital organism. They would just build a ChatGPT-like model using biological data, so that other than simulating language and the reasoning in language, they can simulate how a drug would perturb a biological organism, what kind of consequence you may have, without going to the very painful and dangerous wet lab to do all the experimentations and the physical perturbations. So that's roughly my outlook into the next couple of years. But I want to point out an issue people less appreciate, but is important to make sure that we are on course. So AI provides the opportunity in terms of the physical means. But we, as the user of this technology, need to have the right mindset. What do I mean? This is a mindset. I don't know what to read out of it. I have a horse wagon. My horse is expensive and hard to maintain. How about I replace it with a robot? So old workflow and the new gadgets, right? And this is happening all the time. I have many questions coming to me, say, oh, I got this problem in my workflow. Give me an AI so that I can solve it. I argue that this is not the ideal kind of approach to enter the next 5 to 10 and 25 years. And this is maybe a better mindset. The engine was never invented to land something down. They are used to shoot something up. But someone out there thought differently. They thought the engine actually can be used reversely to land a rocket so that I can make the rocket cheaper. So it's a very disruptive thinking, which could happen, for example, in here. Why we even need to go through this painful, decade-long process of drug trial and development with all these stages, to the point that I can even award a Nobel Prize to a particular solution to one stage, which make it from 1 year to maybe a day. But what happened to the rest of the other stages, which could still take another 10 years? You're not solving the problem, right? So this is what I call to be thinking in this way. It's a great tool, it's a great gadget, but it doesn't solve the problem of drug development. What could be imagined is the following. You have this whole pipeline of sifting and filtering and drug trial, which takes decades. Your goal is to reduce from this zillions number of possibilities into one that is working, right? How about we invent a digital individual or a digital organism, which allow you to simulate all your proposals, possibilities, to get the outcome out of it. I think that is what AI potentially is able to provide, because AI is a big simulator. It is a big computer that can compute faster and cheaper than a human being could do. All right, so in fact, FDA was recently issued a white paper calling for phasing out of animal tests and the wet labs. Right? How to make that happen? Well, I think AI definitely provides one options. I'm about to end. I think the opportunity given by AI is unbounded, but it also requires we human beings to really develop the right mindset and ask the right question so that AI is steered toward a useful and legitimate and also high probable, high return problems that they can focus on. On the other hand, if you just want to develop the feeling of being intelligent, make it very, very magical from a user experience standpoint, I think AI is going to lose its way, and we are going to lose our way. Maybe one last point before I close is maybe a new kind of a singularity that we can anticipating that is all making us very, very puzzled and maybe even scared. You've got the agent, which could do physical word reasoning, social word reasoning, biological word reasoning, and so forth. One thing that is not in design yet is the definition of self. So who am I? Right? That is what really differentiates a biological creature or maybe a soulful creature like us away from any machine, which is very capable in their muscle, even in their brain, but not spiritually inspired. So I leave that question open because I don't have an answer. I think self-awareness is maybe the next new definition of a singularity. If the AI system ever crosses that, we do have reason to be scared and worried. But hopefully, we will be very far away from that turning point, or maybe never going to reach there. So I'm going to end here. Thank you very much.
Thank you very much, Eric. Yesterday, we had a session on the art of predicting the future, and one thing that we heard is that somebody raising questions instead of coming up with certainties about the future is probably giving you a bigger service. So thank you for raising the questions. We don't know what the future will hold. Do we have any questions? Please raise your hands, and we're going to bring you the microphone. The way I understood the final point you're making, I think there was a very useful distinction made in the 2000s when digital transformation happened. There was like the distinction between digital natives and digital migrants. And I feel like what you're saying at the end is that we tend to behave like AI migrants. Like we take the way we work today and we ask, hey, can I have an AI like summarize the meeting? Instead of asking ourselves, how can we completely reinvent the way we work so that maybe we don't have to hold that meeting in the first place, right? Like, is that what you're trying to say, that we need to be more AI native than AI migrant?
I didn't hear that terminology, but I like it. I think, being AI native is it's happening, in fact, and it is going to happen continuously. The AI will be part of your table stake, I would say, in the future. And like you have a washing machine in your home, you have a microwave oven in your home. I think in a few years, AI will be like that. And then there is a very, very definitive goal defined by the function about how AI does things better, or do more things. Yeah.
It's the famous quote from Henry Ford. If I'd asked my clients what they wanted, they would have said faster horses instead of coming up with the next iteration. Karthik Ramani, our speaker from 2 days ago, specialist of extended reality. Your question.
Yeah, thank you. Thank you for your nice talk. So my question is, there have been substantial breakthroughs, deep learning, Jeff Hinton, and more recently, transformer model from Ashish Vaswani and so on and so forth, 2017. In order to make further progress, what kinds of or natures of breakthroughs you think are needed to go beyond the LLMs and LVMs, large language and vision models?
Great question. Obviously, the current architecture used to train large language models is inadequate, to go beyond the language modality. This is widely recognized already, so people are working on it. And there are a lot of debates in terms of how exactly innovation or changes should happen, including very technical things like the embedding, algorithms, and so forth. So that's one thing we know for sure. But I don't think this is anything that the public need to be involved with, because you should just sit back and watch. I think what is really going to change the public sentiment is how these kind of tools can be governed and can be regulated, and also how can they be properly priced. I don't think we have any idea right now in terms of building an ecosystem in this new norm, so that the current very, very expensive and rapid development, first of all, is not very necessarily sustainable because it's very expensive without a clear business model. And secondly, it is very, very polarized. It is only happening in the big industry to the point that academics are playing now not just the second fiddle, maybe the third or last fiddle, because they don't have the equipment and also the resource of doing that. So these kind of questions needs to be answered and also will be answered to redefine the landscape of AI. Where are the immediate problems, which is about engineering and execution, which is the intellectual questions that is more toward a long-term kind of a reward. But AI is unique. It's different from theoretical physics, where you can sit in a room and do things without a big lab. Unfortunately, many of the innovations in AI need to be validated on system. So I don't know at this point how to make the academic community relevant again, so that they can contribute meaningfully to the frontier development of AI systems. Thank you.
Please raise your hand if you have any question, and we're going to bring you a microphone. It makes me think, there's this obsession in the world of innovation that you want to be the first mover, but some markets are actually last mover. And there's a very famous example, which is Google. Mm-hmm. Google was the last invented search engine, and then for 2 decades, nobody created search engine. Do you think AI is going to be a first mover, or there could be a model coming out in the coming months that would be so much better that all the existing players would struggle?
Good question.
Or everything in between?
It's possible. LLM is now sucking all the oxygens out of the room, so most of the people are working on that. It doesn't mean that there are no one working on other approaches. For example, there are a few labs in the world working on word models, although the definition of word model is itself subject to debate. But I imagine some breakthroughs are in the making right now, and when they come out, they will suck the oxygen out again into different places. Like you saw the Sora 2 release, which is quickly jumping into the top of the leaderboard right in the AI app and the Apple App Store. So these type of disruptions is going to happen. But what I'm personally more interested in is to see a different runway where it's not just about the general public's perception about ChatGPT-like applications. It's really the breakthrough in science. I don't think right now there is a consensus in the community of science where how AI in a larger way can be used. There isn't yet a certain type of equivalent to do larger science using AI, where thousands of scientists all collaborate and work on a glorious and noble and big enough vision that really cannot happen otherwise in individual labs. So I think that should be the precursor of what you described to be another disruption.
Yeah. Yesterday, Samsung claimed to have created a model that was 10,000 times cheaper in terms of energy, and so there's still a lot of changes happening. Do we have any questions? I get to ask my questions. I'm super happy about that because I have many. So I guess a lot of people in the room right now, we all have, if you run an organization, you have to ask yourself, how do I bring AI in? So there was step 1, which was like clicking on the I allow Copilot to read my emails and help me a little bit, or Siri, stuff like that. But where would you invest right now if you were an organization having to implement AI? Would you buy some hardware? Would you invest in a model? Or would you invest in your own data, or maybe all of the above?
Above all, I invest on people. That's the most important thing. You need to basically, get the right people with the right mindset to work on the right problem. So that's how I began with. And then once you have the right people, you give them, indeed, resource, hardware and data, and also a forgiving enough policy so that they can make mistakes. They don't have to publish like crazy every day. and they can still work on long-term projects. But it's actually complicated because it is incompatible with many of the ways traditional organizations are operating. So we're still experimenting. But I think in your previous question, I want to go back, which is to make a model more energy efficient, make it more pocket size, and make them more portable and affordable. These are great questions, which is on the apply side. I don't call them disruption because someone is already showing you the way. You just want to optimize it, right? I'm still trying to explore, a space where you can ask the impossible and think about a new application. Like in the morning, we discussed with Mike about what happened to the physics, the universal physics in the 19th century, where it's almost perfect, except two or small, the one little question are left unanswered. So we are actively building an organization which can bring in people, think about their scientific life, their professional life in that way.
Eric, thank you very much for this fantastic talk. To your last point about self-awareness, some people would call that consciousness. Some people claim that will come automatically with embodiment. What's your point? I'll comment on that. And the second thing is, you made the point, intelligence, it's self-referential. It's how we define intelligence. The same thing for consciousness or awareness. How will we identify consciousness or self-awareness in a machine once it would have it? Given that, again, we're not machines, and so it's really hard to relate to how self-awareness in a machine would actually be visible, would happen.
Yeah. I wish I could answer this question. I really don't know. It's very, very difficult. I think, in many cases, I don't know the answer, but I also know what answer is incorrect. For example, by having embodied experience, plugging them into the AI, is that adequate to create a self-awareness? Maybe not, because the reward function, for the AI system is very limited right now. It's maximum likelihood, contrastive learning, and some kind of a recreational power of the data and so forth. We human beings, we learn with a very, very diverse and rich reward function. In fact, every individual among here probably have our own reward function, happiness, and a sense of ego, or many other things. I just don't know how mathematically they can be translated in an actionable way into any mechanical or digital system. So it's an open question. I think maybe there is a process where scientists start to figure out one after another mathematicalization and formalization of some of this reward function. But until you cover the whole human spectrum of all that, it will take decades, maybe even centuries. And then there are other things more than even our function, such as your spiritual pursuit and other type of philosophical capability that humans uniquely have. Yeah, I'm not saying it's impossible, but it is going to be very difficult. It's more difficult than many people would think, that once you build a model bigger and bigger with more and more data, they automatically cross that barrier. I think that there's a gap that is unexplained at this point, how to cross.
So your question, and after we'll go.
Yeah, so just building on that, I'm possibly paraphrasing a little, but when you were talking about self-awareness and you said, oh, if we do get to self-awareness, we'll be in trouble. Why?
We might be in trouble. I'm not asserting it's going to be a trouble. Because it is going to be a new world that we suddenly have creatures that we built, which will be really just like us. We don't know how to deal with that yet. In fact, even now, look at how human beings coexist with each other. We have wars and all sorts of things already. It's already difficult. So all I can say is that a very, very high-level speculation that if more complexity are added to human society, other than the tool, but in terms of the fabric of the society, it is going to be very, very challenging.
By time we will have learned how to deal with trouble, because we have enough on our plate right now. Sir, and then we'll try to take one last question. We're getting very short on time. Please be quick.
Thank you, Eric. Scott Phillips, Vault Adventures. I'd like to dig into the question of advanced AI causing advanced harms. What do you see on the scary side of the future here, and how does your group think about the mitigations of those harms in terms of law or technology frameworks?
Sure. Again, this is a concern, a question, almost coming with any disruptive technology, like the electricity, for example, like the car on the street, like aviation, nuclear technology. We all face that question. I think the answer has been already, thought through history to have a regulation, proper governance, and so forth. But maybe I should add to that. One thing is education. The awareness, of this technology, the way it is now, is not enough. It's very superficial, very, very inaccurate. So in a sense, AI education should be part of the curriculum starting from early so that people know, properly how to use it and what it is. And secondly is about maybe a more natural kind of attitude on AI technology. Yeah, no technology is 100% safe. But if you want to prevent it, the risk by not developing it, or by caging it inside a particular cube, then people will lose the opportunity to experience and to learn and also to develop their own immune. It's like in the natural world, when you put a person in a natural environment, exposing to all the bugs, all the viruses, you don't necessarily make them less healthy. In fact, they will be more healthy and as a society level, more robust. But if you put people into a vacuum where everything is super hygienic, super safe, what if that particular bubble broke, right? So I think I'm taking this view that AI needs to enter, a human life in a controlled way so that people can learn how to use it and coexist with it.
I need your question and his answers to be less than 40 seconds. No pressure.
Very quick. My name is Louise Eggersnap. I lead the WHO Innovation Hub. My question is about, sort of at a meta level, the impact of AI on humankind and whether you think that there is an effect of disempowerment and sort of erosion of humankind's self-confidence in our own creative potential.
Yeah, empowerment always comes with disempowerment because you have to change the course a little bit. It's again education. I think people will find some sense of frustration when they find that a machine do so well. Then I used to be able to break the square root of some numbers, but I never worry that a calculator can do the same. In fact, I choose not to even teach that in my course anymore because the capacity is needed. I think the most interesting thing is to open up new capacity with this new tool so that you find yourself solving harder problems rather than keep focusing on the older problems which can be solved by tools.
Thank you very much. We have many questions, but then we get to take them informally as our time comes to an end. Thank you very much. Please, a warm round of applause for Eric Xing.